All right, we're going to look at the electrostatic and Ohm's law problem types today. The electrostatic and Ohm's law problem types, the reason we do this is filling out that green sheet, is so you can first understand what type of problem am I trying to solve, and then what are some key things I need to do to solve that problem. Now, a more in-depth look at how to solve those problems is in those videos that are in the video library link down below. All right, so the first type we have is electrostatic force. This is when we have two charges. There is going to be a force between them. So we use this equation, which is known as Coulomb's law. So the force is equal to the Coulomb constant. So we stored that on our calculators in class. Times Q1 times Q2, absolute value. So we're not worrying about what the sign on the charge is. All divided by R squared, the center distance there. In order to find the direction of the force, or if we're using this equation to find the charge, we'll find the sign this way is like charges repel, opposite charges attract. So that's how we get the full vector with magnitude and direction. Now, if we have an equilibrium setup, so now maybe I have two charges, I want to find where is the equilibrium point in between where I could put some charge and it would just sit there. No net force. So this is a first law problem with electrostatics. That means we're doing equilibrium. We have balanced forces. Okay. So we are still going to be doing electrostatic forces, but we also have all these other steps to go. Now, if you're just trying to find maybe one of the charges that makes that an equilibrium spot, you can go ahead and just jump right down to summing up the forces, setting equals 0, substituting and solving at that equilibrium point. If you're actually trying to find the equilibrium point, you're going to need to follow these first few steps here to make that a little easier for you. So the first step is you have to identify the location of equilibrium. Now, when I say location here, I just mean the region. Is it outside? Is it inside? Okay. And then you need to choose the origin as the left charge. Now, if they already chose the origin for you, go with that one. If not, you get to choose it at the left one. Now you need to define from the origin to the location of equilibrium as a distance r. Now you're going to find from each charge to that equilibrium location in terms of that r you just defined. What this step does for us is it goes ahead and gets us a single variable in our distance calculations. That way when we sum up our forces equal to 0, we have one equation and one unknown, that single r. Go ahead and substitute using Coulomb's law and solve. All right, now moving away from those electrostatic forces, now moving into the movement of charge, we're going to be doing current. So current is whenever we're moving charge. The equation for current is that current, this I value, is equal to how much charge did I move in how much time. So how much charge moved past a point in a wire in a given amount of time. And sometimes we'll talk about this amount of charge as equal to n times the charge on an electron, where n is the number of electrons that have moved through that point. So if we ever want to talk about the number of charged molecules or electrons or protons, whatever it may be, this is where we would do that. We'd have to use the charge of whatever the thing that was moving, and typically it's electrons. So we typically say it's the number of electrons times the charge on an electron. Now moving over to this side and keeping on moving down your green sheet here, we have resistance. This is when we're dealing with the resistance of an object, of something. And so that resistance is equal to the resistivity, this is a property of that material, times the length divided by the cross-sectional area of that material. Ohm's law allows us to relate voltage current through that resistor. And so we're able to say the voltage is equal to current times the resistance. Now, power and energy. So now I'm looking at how much electrical power is something using, or how much energy did it use in an amount of time. So the power is equal to the current through it times the voltage drop across it. Or I could talk about the amount of energy it uses in an amount of time. That'll tell me about the power. And again, power is measured in watts there. Now, just to bring this into the house and stuff, we can talk about the cost of that electrical energy. And so we can talk about that cost of electricity is maybe another term you might want to use there. So cost is equal to the electrical energy times the rate. And so this rate is what the power company charges you. And this is typically in the units of cents per kilowatt hour. And so that means you're going to need your energy in kilowatt hours. So if we think back to this equation up here, you're going to need your power in kilowatts, your time in hours when you do that calculation for cost. So there are problem types. And again, if you want to see a more detailed explanation of how to solve these different problem types once you've identified them, go ahead and click into that link for the video library below and find the one you're interested in.